no electricity. Now I can't watch Spider-Man. Is this still even good? It's so stale. Makunat. Huh? Why is there no light? The fridge is not working. It's plugged naman. Ever. Need to reheat this. Still not working? Why is it not working?
I think those are the things would happen if matter is not mixed well.
Oh, you're right. Because matter and properties are around us. Everything around us is made of it. Even the air we cannot see. From skyscrapers to the submarines, matter is to be used and seen.
Though we talk about the worst case scenarios that may occur when matter is not utilized, I still wonder how solid, liquid, and gas works and where can they be used. There are some scenarios that offer
Okay, class, that's all about the last matter. Does anyone want to have an additional question? Yes, Judasa.
Miss, may I ask about how solids are used in infrastructures?
Good question. There are three commonly used solids in infrastructure, which are steel, concrete, and woods. Steel and cement are used due to its stability and strength necessary to prevent massive buildings from collapsing, while wood is valued due to its strength, flexibility, and practicality. It can be cut, glued, nailed, and basically anything you want it to be.
But, Miss, what is wood made out of? Because my father always burned wood to cook, and I always wonder how it just disappears.
Mm. Wood is made up of a complex mix of natural fibers. Also, when wood burns, it doesn't just turn into fire, it actually turns into gas and ash through a chemical reaction.
Yes, that's right. It's also very important for our infrastructure, especially our industry.
Though infrastructure is one of the many things solids can do, I still have an idea.
what is it?
Nak, can you hand me the screwdriver?
Here po. Pa, I have a question. How do you fix those? And my classmate asked me how microchips are created for our science project.
Oh, by manipulating the crystal lattice of silicon, engineers can control electrical flow to create microchips.
Well, how about ano, conductors?
Um, you can change the behavior of silicon and turn it into conductor by doping it. And there are two types of doping. First is N-type. Phosphorus or arsenic is added to the silicon in small quantities. So they each both have five outer electrons. The fifth electron has nothing to bond to, so it's free to move around, and it takes only a very small quantity of the impurity to create enough free electrons to allow an electric current to flow through the silicon. And lastly, the p-type. So boron or gallium is used. They both each have three outer electrons only. So when mixed into the silicon lattice, they form into a hole in the lattice where a silicon electrons has nothing to bond to. And the absence of electrons creates the effects of positive electrons.
Oh, now I know. I will share it to my classmates. Thank you so much for answering my question.
Especially in our era where we use technology almost anywhere. True, but why am I your daughter, your idea?
It's just an example.
Okay, back to the topic. I still have one more example for solids.
A few moments later.
So, is my condition critical?
It's not critical to the point it needs concentration, but you may not be able to walk properly, run, and play basketball.
May I ask what is integration, Doc?
Of course, oscillation is used mostly when you get amputated. It allows living bones a direct structural and functional connection with the titanium surface, made ideal for permanent implants.
Oh, good thing that my condition is not critical. Thank you, Doc, and I will be careful next time.
So solid can also be used in medical field?
You know, right? Salts can be used in so many things.
But do you know what's way more cool about solids?
What is it, Chab?
Do you know that when heated, the Eiffel Tower expands, making it slightly taller during summer? And the next fun fact is, since silicon is in phones, people usually think it's a metal that carries electricity easily. But it's actually a semiconductor, meaning it only carries electricity under certain conditions.
Oh, really? I just learned that today. Thank you, Sam. But how about the second state of matter?
Oh, right, the liquid state.
Wait, I know example about liquid. Do you guys want to know?
Yeah, sure. Hello, what happened?
I think the car broke.
What should we do?
You should call mechanic.
Let me call someone. Hello?
Hello?
I think our car is broken po. Can you come and help us?
Oh, okay. I'm coming.
Okay, thank you po.
A few moments later.
It seems like there's a problem regarding the brake.
Check out the brake.
Excuse me, sir. May I know how car stops?
When you press the brake pedal, it activates the master cylinder, which converts your physical effort into hydraulic pressure. So the brake fluid in the system transmits this pressure through the brake lines to the brake caliper or incompressible. The pressure is evenly distributed, allowing for consistent braking force. This hydraulic pressure forces the brake pads or shoes to clamp onto the rotors or drums, creating the friction needed to slow or stop the vehicle.
Why is it important that the fluid is incompressible?
Incompressible fluid allows for the multiplication of force, where a small input force creates a much larger output force as the pressure is transmitted equally throughout the entire system.
Oh, thank you po, sir.
So that explains how liquid works in cars or vehicles.
Amazing, right?
Yes, it's cool. Also, me and Daryl have learned something about liquid.
What is it?
Do you know, people often clump gas and oil together as car liquids, but they do opposite jobs. Gas is burned for energy, while oil stays as liquids to keep the metal parts stuck tightly together.
Also, do you know that liquids can stack based on density? That's why people can float so easily in the Dead Sea.
Whoa, that's an interesting fun fact.
It's cool, right? How liquid can be used in different ways. Wait, I think we're forgetting something.
What is it?
Oh yeah, the gas lid. Wait, I know some example for gas. Do you guys want to know? Yes, yes, yes!
Off your clothes, let it show. Money never fold. You my rider till we die. You my angel in the sky. Blowing kisses like a blunt. Baby girl, I'm tryna stunt. You can be my number one. Won't you be my bubble gum? Yeah. Won't you be my
I kinda want some chips now. Ba't bang kunat?
Do you know when exposed to air, foods such as potato chips absorb moisture and go stale and soggy quickly? Atmospheric oxygen also reacts with the unsaturated fatty acid present in foods, resulting in rancid off flavors. Unlike the air you breathe every second, nitrogen used in food packaging contains very little oxygen and moisture. Nitrogen is not reacting with any food components, odorless and tasteless. When nitrogen is introduced into packaging, it drives out oxygen and any moisture present.
That's why it's makunat. Cause when I took it, it's already deflated.
A few moments later.
Why is the gas not working? Let me Google it up. Okay, so gases are highly efficient fuels because they mix easily with oxygen, allowing for clean and complete combustion. Natural gas or methane is used in stoves. It is piped directly into homes because it is easy to transport as a pressurized fluid. A natural gas furnace operates through a precise continuous cycle to deliver warm air to every room in your home. When the thermostat calls for heat, natural gas flows to the burners and is ignited. Then the burning gas heats the heat exchanger, a metal component that separates combustion gases from the breathable air. I still don't get it. I should just probably call mom.
At least I know I'm not the only one who got the makunat chips and having a hard time in opening the gas door.
I will learn more about gas. It's so interesting.
Me too!
I wanna share some fun fact I learned about.
What is it? Share please.
Do you know that air can inflate a balloon on its own since warm air expands? The principle that warm air expands and becomes less dense, allowing it to rise and inflate a container, is the foundation of hot air balloons. The Montgolfier brothers, Joseph Michael and Jacques Etienne, used this principle to create the first successful hot air balloons in the 18th century.
Wow! I've learned so much about that. Bali, wala ka nang hawak na pera at magtanghaw.